That's how it works, yep. All right, everybody, welcome to the first class of ESAB University at the 2018 FABTECH show here in Atlanta. So there's this class, and then we have two other ones with both Jody and Bob. So each of us are teaching different things. So I'm going to be teaching you all about the wonderful world of roll cages. So who's a fan of football? Everyone's a fan of football, right? Okay, so here's how, you may not think that relates to a roll cage, but it does, believe it or not. Here we go. So not too long ago, my son started playing football. He's now 6'2", 220 pounds off to college, but I don't know where he gets it, but that's where he's going. So he started playing football at the young age of 6 because we live in Tennessee, and that's when he started playing football there. And he played on the offensive line. He started on the defensive line, and then he moved to the offensive line. And one day he came home to me and he said, "Dad, how come when you win the game, the quarterback always gets carried off the field, but when you lose the game, the offensive line always gets blamed?" And that's because the offensive line is made up of some key players. Now you basically have your center, right, left guard, left tackle, right tackle. Each one of those people have one very important job on that offensive line. Now if they make a mistake, if one person doesn't do their job on that offensive line, the whole game ends, kind of like that. Helmet right off, that's one person didn't do their job, and that was the end of that game. A roll cage is no different. Roll cage is a complicated piece of machinery that has a lot of parts and pieces. Each part and piece has a specific job. If one part doesn't do their job, the entire cage fails. Doesn't matter how well you built the main hoop, how well you welded it together. If it was designed incorrectly, the entire cage or chassis will fail at one point in time. And your day will end up much like the quarterback with your head coming off, but you won't have a helmet on. So, first step to designing any roll cage or chassis, it boils down to whether or not you're designing it to race or for recreation. Now, if you're going to race, there's a bunch of different sanctioning bodies that you have to abide by, and you have to look at that rule book and decide how the cage needs to be built. They'll give you specific tubing size, how it needs to be built. They'll actually lay out the exact size and space of the cage, how it needs to be put together. They'll often require an inspection. If you're racing off-road, you're usually dealing with SCORE or Ultra 4. If you're racing rally, you're using the SCCA or NASA. Now those two sanctioning bodies will basically tell you how you want to build your cage. The good news is, if you're building it for recreation, just for fun, there are no rules. You can do whatever you want, but it still needs to be safe because the roll cage is going to be your last line of defense when something really bad happens. Okay, so you do have the freedom to do whatever you want, but you need to follow those certain rules and make sure everything is designed correctly. The good news is we can actually take all the rules and regulations that apply to a race cage and use that to come up with a plan to build our recreational cage. So this is a book out of the required main roll cage structure out of a rally racing handbook. So you can see it'll basically give you the 4 main designs as how you're allowed to build your cage. And this is basically how all cages start. You're going to start with the main design of the cage, and you have a few different choices. Okay? Top left is what's called a main hoop. So that's the kind of cage where you'd have a B-pillar hoop that would be behind the driver, go up over your head and down the other side of the car. That is a very popular design for something like drag racing. You're inside the car, the cage has to fit inside, and you'll see a lot of B-pillar hoops inside of there. The next one is what's called a continuous A-pillar, which basically means that your A-pillar goes up along the windshield frame, down the roof line, and either straight back down or all the way back to the back of the car. Then there's also the halo cage, which you'll see a lot. The halo cage is this one down here. That's a halo hoop where you'd have a main hoop, and then you have another hoop that comes around the front and 2 kickers that come down the front. Which cage you choose to build will either, once again, determine whether or not you're racing the car or if you're just out to have fun. The most popular cage for off-roading is going to be your continuous A-pillar type of roll cage. You'll see that used a lot in Jeeps and desert trucks and all that kind of stuff, and it's my personal favorite one to build because it's actually a lot easier to weld. because of how the joints go together. There's a few rules that we have to follow with any cage, and the rules are you have all your tube intersect points have to meet. So if you look at a cage design, you'll see that whenever one tube meets one side of a piece of tubing, there has to be another tube on the opposite side unless that's the end. So if this tube hits this joint here, the tube on the opposite side can't be offset in any way. It has to be directly in line with that tube. So what you're doing is you're allowing the force of the crash to travel through the tubing, through the joint, and out the back side. If the tubes were offset, you can actually have the cage shear in the accident. So the tube will push past the secondary tube. You want to create what's called a node. A node is when you have a large number of joints meeting at one place. We've got some pictures of some nodes later on. And then gussets are the one thing that everyone forgets, and then how to attach it to the chassis is a lot of things that people skip out on too. But you can get all that stuff from each rule book that'll give you all that information. So you can see here, the top left, that's pulled right out of a SCORE handbook. That is the desert racing cage. That's sort of your gold standard of roll cages, because if you've ever raced off-road desert racing, you crash your truck every race. That's just part of life, and you want to be able to go home after that. So you can see that you're basically making a driver's compartment in that cage with a lot of intersect joints with tubing that is going to allow that pressure to be moved around to the rest of the chassis while the driver stays safe. Gussets are done. You have two types of gussets. You either have a flat plate gusset, which has to travel down the middle of the tube joint and the middle of the secondary piece of tubing, or you'll have what's called a saddle gusset, and that's that bottom picture. Saddle gussets are popular in road racing and drag racing as well as rally racing. I don't know why, they just like them. There's really no strength benefit to a saddle gusset, but if you do any rally racing, you'll see a lot of saddle gussets. And then the very bottom is your floor, your mounting plate to the floor, and you'll see how it basically bolts through. There's a plate on top of the floor, a plate below the floor, and then everyone forgets these gussets right in here, which are the two gussets at the bottom of the tube. Whenever you're working with a cage, you always have to think of how it's going to shear off, because it's going to shear off. So if you have the tube just sitting on that plate welded without a gusset, it will shear off that plate. You need to add more weld area. So if you sat down tomorrow and designed a cage or designed a chassis and followed all the rules, that's what it's going to look like. So it's going to look like an incredibly complicated jungle gym of tubing with a whole bunch of straight bars and a few curved bars, and you have to sit down and be able to design that, figure it out, and make sure it's safe. Now, it can seem incredibly overwhelming because there's a lot of tubes there and a lot of bars there, but you just start by breaking it down into each individual section. So if you look at the section, the first step is just sort of deciding which type of tube or main hoop you're going to run. What's that? That's just extra. Thank you, though. I'll get that later. You can have that wire for finding that out for me. I appreciate that. That's my present to you. So it all starts by determining which type of cage you're going to build, whether it's going to be the B-pillar cage or you're going to do the continuous A-pillar. You can see that the B-pillar is basically goes over the driver, and then it has front bars that get connected. The continuous A-pillar is the bottom right, and that's the one that comes up the A-pillar and then goes all the way back. The reason we like the continuous A-pillar in off-road, the B-pillar cages get hung up when you're driving off-road because they do stick out if you look. This would be the example of a B-pillar. So that front bar would come in and hit the edge of it. If you were in the dirt and you were driving through rocks, the edge sticks out and gets hung up. Versus a continuous A-pillar just kind of goes on forever. So if you lean over into a tree or a rock and crawl it, it'll just keep going. Okay, so that's basically the design elements of it. So once you pick what you're going to design and how you're going to build it, then it comes to welding it. Now, who here has ever welded a cage before? MIG or TIG? What? Which do you prefer?
MIG's easier.
MIG's always easier, isn't it? It's the best. Yourself?
MIG, but working on TIG.
MIG, but working on TIG?
Done both. I like the accuracy. TIG better.
You like how it looks after? Yeah. So there's really, depending on what you're going to use it for, at the end of the day, there are some sanctioning bodies that are now specifying a TIG welded joint, and the way they word it is they'd want continuous weld throughout the entire cage, which is very difficult to do with a MIG gun, especially inside a car. So there is some benefits to welding with a TIG welder at that point in time. MIG welder is always faster. So to give you an idea in your head, if you were to thinking whether I'm going to MIG weld it or TIG weld it, if I was going to MIG weld a chassis that I built in my shop, it's about a 40 to 45 hour weld out. If I'm going to TIG weld it, it's 120 to 160 hours. So the time that it takes to TIG weld that, you are expounding that like 3 times over, and that's if you're lucky. The majority of the stuff that we do in our world is all the mild steel tubing. So we do a lot of MIG welding just because it's faster and it's cheaper, obviously, in the long run, which most people like. Strength-wise, if there's arguments on both sides of the fence, which one's stronger. I've seen both wreck, and I've seen people walk away out of both car accidents. So, you know, TIG, you do have more control over that final weld, more control over the puddle, but you can MIG weld a cage and it works just fine. Who here stitch welds their cages together? Good, I'd throw you out. Stitch welding is something that we've seen a lot in our world, at least in the off-road world. I don't know why. Does anyone know what stitch welding is? Yeah, you know?
Are you talking about like point and skill?
Trigger. You know those tack welded cages? Not a fan of those. I don't believe that the science is there to justify it. I've seen wrecks with those and they fail because you don't have enough heat input into it. So when it comes down to welding it, I gravitate towards a lot of MIG weld because it's just quicker, faster, and easier in my world. So I'm going to show you guys a quick, simple joint here. Now I get to get behind here. So this would be a very typical setup that you'd find on a B-pillar hoop. So you have your B-pillar coming up and coming over, and then you have the second one coming in. This would be like a crossbar that would go down to join it together. One tool that is super duper handy if you're going to do a lot of tube work is this little third hand tool here that we got set up. It basically, there's a lot, Chad, look at all the wire on the floor over here. That's for you, buddy. So you can pick these up from a bunch of different fab shop supplying places, but it basically just helps when you want to hold it in place, tack weld it. It's adjustable and just clamps onto a bunch of different size tubing. One thing that we did not talk about was the tubing size selection. So if you are building a vehicle to race, they will tell you exactly how big the tube has to be, how thick the wall thickness is, based on how much the vehicle weighs. So you have to start there. You need to know how much your race car is going to weigh. Good rule of thumb for pretty much all trail trucks that are under 5,000 pounds is 1 3/4 120 wall DOM is what we work with. Some NHRA older rules would do 1 5/8, and some rally stuff is like 1.5 inches if you're sub 4,000 pounds. Once you cross that 5,000 pound mark, we usually step up to a 2-inch tube on all of our main structures, and then we use 1 3/4 to fill it in. But the majority of off-road trucks out there are going to be running an 1 3/4 120 wall DOM, unless you step up to some chrome moly stuff, which is, well, that's just spending money at that point, but you can. A lot of the desert trucks, we use a chrome moly based tubing because they build in monocoque structures, so you'll have a front end, a driver's compartment, and then a back. And the chrome moly tends to be able to handle a crash better than mild steel. Mild steel will twist and bend in a crash, where the chrome moly tends to hold its base structure a little bit better. So when you wad the car up, you can just cut the front end off and rebuild only parts of the car. Mild steel tubing car is usually, if you wad it up, you got a lot of, it's twisted up. But if it's a trail truck, that's why those suspension bars have threaded heims on both ends. You just twist it back and start driving again. All right, so there's a lot of different ways to cope the tubing or notch the tubing, as people say, that in order to fit around another piece of tube, obviously it has to, you can't just stick it on there and weld it. You have to notch it. You can buy a notcher, you can hole saw notch it, you can do the whole hole saw, or the 9 times out of 10 I end up just grinding it, because you're going to end up grinding it anyway to make it fit better. So on a joint like this, I'll usually just end up with a flap wheel and a hand grinder and grind it. That's what we do. So we'll start with that. Hey, buddy. Just gonna point that right at me right now. All right, any questions before we start grinding on a bunch of tubing? Man, you guys are easy. It's the easiest class ever. All right, here we go. So whenever I start with a joint, I'll usually start with a piece of tubing. If it's an incredibly complicated joint, what I'll sometimes do is come in and use a piece of scrap tubing and actually make the joint first. It seems like it's a waste of tubing, but it actually helps you out in the long run if you can come in and you can actually just get that joint set up perfect. This is kind of the best way to, you want these to be as tight as they can be. So I'll normally come in with I just a normal paint pen and just come in, and all I'm doing is I'm just trying to grab the profile of the bottom tube and the top tube. All you have to do is, this is sort of like a trial and error kind of thing. That'll work for now. Now, a step that most people, well, not most people, I've seen people do it all the time, they'll skip, is once you get a half decent fitting joint on your cope tube, if you're TIG welding it, it's just second nature to go ahead and clean off all the mill scale and clean off all the mill scale on the bottom piece. But usually when people are MIG welding it, they kind of skip that step because it's all about speed at that point. But it's always a good idea just to come back and clean back all the mill scale, as well as on where the joint's actually going to join in. So if you want to do that, it just helps with that final weld out type of thing. So we'll go ahead and do that. Another thing that's a good idea to do is you can see, you want them cleaning this back at an angle. That way it'll prevent a lot of undercut in that bottom tube. Hands aren't strong enough. There we go. Oops, I missed. We'll just pretend I grinded that. I'll just hold my hand up here like this, you won't see it. All right, so at that point, the tube is ready to weld. Now, if you were building an entire chassis or an entire cage, you've got two options. Number one, tack weld it all together, or weld as you go. Now, depending on how complicated it is, it's really a decision as to whether you want to spend time now or later. If you haven't built a lot of chassis or a lot of cages, I would suggest tack welding everything with a good set of solid, like 12 o'clock tacks. So you do one on either side, bottom and top. That'll keep it from moving as you assemble the rest of the cage of the chassis. Because what's going to happen as you travel down that chassis and keep adding tubes or adding bars, if it's your first or second or third one, until you've done a good 20, you're going to change stuff as you go. That's just how it works. You're going to be in there and you're going to get it all put together and you'll be like, oh, I want to move this bar a little bit. So it's a lot easier to cut a tack out than it is to cut a weld out. Okay, so this is what I'd normally do. So a couple little tips about tacking the cage. If you're gonna TIG weld it, you want really tiny little tacks because you're gonna be pushing over that with the TIG welder. If you're gonna MIG weld it, you can make a little bit beefier tack because you're just gonna weld from tack to tack on the joint. So if I was gonna TIG weld it, the tack welds would kind of look like this. I'd come in here and I'd set up in this valley here and I'd give it one of these. And that's it. Because that, if you put 4 of those all the way around in an entire cage or a chassis, it will hold it while you're working. Then when you TIG weld it, you can actually come in here and you can just push over it. You can tack it with the TIG welder as well if you want. It's just a little bit trickier to tack it all into place. If I'm tacking it, if I'm going to MIG weld it, I put a little bit beefier tack and I go on all 4 corners. So what I do is I'd come in here. Can you see that? I'd come in here and this cope joint has basically a good stopping point right there and right here. So I'd come in and I'd tack at those 2 spots. And I'd always start the tack heavier on the actual piece of tubing that hasn't been notched and then move it to the piece that's notched. One like that, then I'd come down here and do one like a. Two on this side, 2 on the outside. You do one on the bottom, 1 on the top, and then it's not going to move around on you when you weld. Then when it comes to welding it, all you're basically doing is welding from tack to tack. You can push over some of the smaller ones if you have to. Depending on the rule book, it sometimes will say that you need that continuous run, but that's very difficult to do with a MIG welder, especially inside the car, to get all the way around. I like to go on one side, let it cool, and then come to the other side and let it cool. I find if you push it all through at once, there's a greater chance that the chassis is going to start to move around on it. Any questions? You guys, so easy. What are you doing, buddy? All right, one other thing. Give me that HDMI cord there, Chad. So you can see this is obviously an incredibly complicated joint that would take a long time to put together, but that's what's called a node. Whenever you're planning a cage or a chassis, you want to plan for a large number of nodes that will connect tubes together in one spot. That is where all the energy of the chassis will end up in the case of an accident. So if you have a node like that, that's going to basically make the entire chassis a lot stronger. On the left, we have slugs. Slugs are used basically when you want to join 2 pieces of tubing together. You can't just take 2 pieces of tubing and butt them up and weld them all the way around. That's not obviously strong enough, and it's not going to last in an accident. You have to use what's called a slug, which is a special tube that fits inside the tube, spot welded on either side, welded all the way around, and you have to treat a slug just like you would a corner joint. If you have a piece of bent tubing in your chassis, it has to have another piece of tubing supporting it. That piece of bent tube is what's going to start a failure point. So every time you have a bend, you need to have some type of tube attached to that bend to make it stronger. A slug needs to have a piece of tube basically pulled right down the middle of that joint. If you don't have a tube in there, that's going to become a failure point inside your chassis. So in a case like this, if we come back and look at If we look at this, we're gonna walk by the speaker. So if you look at a standard Jeep cage like this, you will see that right there at that A pillar, there is a slug in that joint. And that is because the tube that starts on the floor, goes up past the windshield, comes all the way back and down. That tube is incredibly hard to make in one shot. Most guys won't do it. Pardon me? How big does a slug have to be? So I thought that was me. So the rule of thumb is it has to be normally two times the length into the tube as the size of the tubing. So if you're 2-inch tubing, you need to be down at least 4 inches on either side. Sort of the rule of thumb. If you can't, because obviously that slug has to fit inside there, if there's a bend, you get it as long as you can. And then you want to leave a gap in there about 1/8 of an inch, so when you weld it all the way around, grind, you'll find the rule in roll cages it's like the ultimate. If you own a grinder, you're not a welder, you're a grinder. Most cages, you can't grind the welds no matter what, no questions asked. And no race sanctioning body is going to let you grind a weld off. They will let you finish a slug out, as long as you tell them where it is. So if you wanted to grind off that slug, most sanctioning bodies will let you finish out that slug so it doesn't have those big welds protruding from the side of the cage. But that's the rule. It's twice thickness of the tubing down either side. So you can see that cage, and then you can see the Jeep cage. You can see how every tube, this tube joins at basically the C pillar. All the tubes end in that node section. So everything needs to be attached together in that way. There you go. Now you know how to build a roll cage. It's that simple, right? So some things you need to get if you're going to build a roll cage, aside from obviously a tube bender, and you can get a tube notcher, or you can do it all with a grinder if you want. It just takes time. Couple tools are, get you one of them bad boys right there. That's going to be your best friend in the whole wide world. So this is a big, long, like sort of protractor-y bit. So that helps when you're trying to figure out the angle that you're going to need to notch that tube at. You can set it up, take it over to your bender, put it in place. If you know the bend's going to be, you can actually set it, mark the tube. Another great option is a computer program called FABTECH Pro, which is an awesome software design program. It's not hard to learn, but you can basically design all these cages in FABTECH Pro. It'll give you all the rules and all the basically bends and how to bend it in your tubing bender. We talked about the little third hand, which is super handy, and your other best friend is going to be a good paint pen and a flap wheel. That's it. Aside from that, you need a welder and a whole lot of time. And if you make a mistake, if you're notching this piece of tubing or making one of those nodes and you jack it up, don't just leave it in place and jump the gap or put TIG wire in with the, has anyone done the MIG TIG fill a gap trick? Don't be that guy. Just take the tube, set it aside. When you're building a cage, you'll use it somewhere else inside that cage, I'll guarantee it. You'll want a short little piece of tubing at some point in time. So if you screw it up, just set it aside and start over with a new piece of tubing. All right, there we go. No questions, comments, concerns? Did everyone get their goodie bag? Thanks for coming, everybody. I hope you had fun at ESAB University. Madeline's got your diploma.